Great, thank you very much. Well, if we had known you wanted a panel, John and I could have argued back and forth a lot. But anyway, it's really great to be here. This has just been an outstanding conference, and we've learned a great deal. I think one of the things that strikes us in comparing cybersecurity with physical security is how, even though physical security, the realm we work in, is many thousands of years older than cybersecurity, it's not nearly as developed or well understood. I think you young whippersnappers with your computer technology have done a really good job given the challenge you face with cybersecurity. Part of the problem in physical security is I think the best minds go over into cyber, leaving only drooling morons like ourselves to work on physical security. This talk's basically a primer about tamper detection and about tamper indicating seals. Then we're going to talk about attacks and vulnerabilities of seals. Now, just a caveat, we're not allowed to show specific attacks on specific seals, but we really don't have to. Our claim is that anyone reasonably resourceful is going to be able to figure out how to defeat seals, even seals used for very important critical applications. That's the case at least for current seals, the way they're currently designed and the way they're currently used. We'll then talk about what we think are better approaches to doing tamper detection, and we'll demonstrate a few things that are really just in the early prototype stages. Well, John and I are with the Vulnerability Assessment Team at Argonne National Laboratory, just outside Chicago. We work on a variety of different types of physical security problems for a wide variety of different sponsors. We try to look at not just the technology, but also the human factors and the human and the social organizational issues associated with security. In the end, as you well know, security is more about really the human factor than it is about the technology. Just quickly, some of the things we do. We'll talk about the seals and tamper intrusion detection we do. We do a lot of things with cargo security. We were the first to show that it's real easy to spoof Global Positioning System, not just jam. I think we were the first to suggest countermeasures, but of course nobody's using them. We've defeated a lot of different biometrics and access control devices, RFIDs. And recently we attacked an electronic voting machine from the voter's end. And why that's interesting is because it means you don't have to, as an adversary, understand the microprocessor, the firmware, or have any kind of access to the microprocessor or the EPROMs. Remarkably, most electronic voting machines have little or no security on the voter's end, and the voter can reach in and fool around with electronics very easily. Other kinds of things we do: product authenticity, nuclear safeguards, a lot of vulnerability assessments, consulting, and again, the human factors issues, we work with industrial organizational psychologists to take a look at security culture and climate. Some definitions. A lock, of course, is a device meant to delay, complicate, or discourage unauthorized entry. Doesn't stop it, as you saw in the tool demos. Almost anyone can defeat locks if they're sufficiently motivated. On the other hand, a tamper indicating seal or tamper indicating device, TID, is something meant to try to leave behind evidence that there's been unauthorized access. Now, if you're like most IT people, your exposure to seals are probably more or less related to little sticky labels that you put on hard disks, computers, maybe on envelopes with passwords for end users. That, for the most part, is security theater. There's no effective tamper detection there. If the little sticky label doesn't even have a unique identifier, like an identification number or a serial number, now you're moving from the realm of security theater to basically magic and superstition. There are ways to make sticky labels have some kind of effective tamper detection, but believe me, you don't want to do it because it's a real pain in the butt. We'll talk a little bit about some of those ways. So when we talk about defeating a seal, what do we mean? We mean we open the seal and then we reseal without either using the original seal or using a counterfeit seal. But here's the key thing: it has to be done without being detected based on the inspection protocol that is being used. So attacking a seal is just attempting to defeat it. Now, sealing goes way, way back. Probably the earliest cavemen and women would basically smooth the sand in front of their cave, and thus they could tell when they left if a cave bear or some other people had gone into their cave and stolen their stuff. That's a type of tamper-indicating device. We know that sealing, though, goes back at least 7,000 years because you can find ancient seals in museums all over the world. Typically, the early seals were just some kind of pattern, sometimes geometric, or a symbol of an animal, imprinted on a piece of stone, wood, or bone. This would then get imprinted into clay and later on wax or resin to leave a unique pattern, which could be used to seal things. And then about 3200 BC, a real killer app came out. Some clever person decided to put the carving on a cylinder. Now you could roll a cylinder up and down and create a replicating pattern. Didn't really improve the security, but it was extremely cool. And that killer app lasted about 1,500 years, and to be replaced in about 400 AD by the lead wire or lead string seal, which you see in the lower right-hand corner. This is basically, you would take a string or wire, wrap it around the thing of interest, put the string or wire through a blob of lead, and then squeeze a pattern into the lead. And the idea is if someone tried to break in, they'd either have to cut the string or wire, which would be hard to repair, or they could tear up the lead, but then they'd have trouble replicating the imprinted pattern. And some of the seals, even fairly far back, are just magnificent pieces of work, like this Minoan gold signet ring from 1500 BC. The way this would work, in the early days when writing was invented, about 3500 BC, they wrote things on clay tablets and stuck them in clay envelopes, and then they'd imprint a seal pattern on the envelope, and that way you could tell if somebody had been opening your mail. If you had a container, you could wrap an animal's skin around it, tie some string, put the clay onto the string, and then again imprint your pattern. And if anyone tried to break in, they'd either attack the string, the animal skin, or the clay, and then they'd have to replicate that pattern. So documents could be sealed up. And the ancient Egyptians had this clever design with a woven box where there was essentially a wooden dowel that came in from the front. It had a hook that engaged a loop underneath the lid. They would rotate the wooden dowel, that would close or lock the lid. Then they'd put clay on the front face of the dowel, imprint the seal pattern. Now, if someone tried to break in, they'd either cut the woven basket, which would be detectable, or have to take the clay off in order to rotate the wooden dowel. But again, they wouldn't be able to replicate, at least in theory, the seal pattern.
Okay, so some more definitions. In the world of seals, a trap is a covert seal. So imagine, if you will, the hair in the door jam trick. That's not a really good technique if everybody knows it's there. They'll go grab the hair, go in the room, come out, put the hair back. So you want to be covert, stealthy. There's also the barrier seal. This is a lock and a seal all in one device. From our experience, you neither get a good lock nor a good seal from such a device. They're very easy to defeat. A tag is a unique identifier that uniquely identifies an object or container. For example, a barcode uniquely identifies a product at a store that you can go and purchase. Lifting is removing a tag and placing it on another container without being detected. Not being detected, stealth is basically the key for being the bad guy in the seals world. A seal is not a lock. It's not meant to keep anybody out. What it's designed to do is record unambiguously that tampering has been detected. It's usually done by some sort of damage that's on or around the seal. So yanking a seal off of a container is not defeating the seal, because if an inspector comes by, they're going to see the seal's not there, they're going to know something's up. Now, in our opinion, all seals should have a unique identifier. They don't, but they should. Also, since seals are supposed to unambiguously record that tampering's taken place, you should inspect it from time to time. A seal that's never inspected is pretty much worthless, but this happens in the real world. Now, defeating seals is mostly about defeating people. It's not like locks, safes, and vaults where you're actually going after hardware. Yes, you're going after hardware, but you're trying to fool a person. That's the end result of this. Now, a seal is only as good as the recipe in which it's used. All of these are very important in the seal process. You have to have good chain of custody. On this list, I would call out how you install the seal and how you inspect it are very, very important. Unlike seals, a real-time monitoring system or intrusion system will, if tampering is detected, will automatically raise an alarm. What we see a lot in cargo shipments is they'll have real-time monitoring systems, but if your cargo's in Peru and it gets hijacked, if you've got no force to respond to the alarm condition, there's no real point in having a real-time monitoring system. You can instead spend your money on, you know, other avenues of security. Like I said, if you can't respond, there's no point in having it. There are a lot of different kinds of seals out there. Nobody really knows how many. We think there are somewhere in the neighborhood of 5,000 or so. The applications vary. They're all over the board. You're probably most familiar with the seals used on products in the stores for like your drugs, your food, stuff like that. Those are all the seals, types of seals. Roger's going to pass out some seal examples. But before he does that, he has a couple things he wants to say.
Yeah, I'm going to pass out some variety of samples. Just a disclaimer. We're not saying these are good or bad. We're not saying we've analyzed them. We're not saying we haven't. They just give you examples of seals. Some of them are opened and some of them are closed. We'd ask you not to close the ones that are opened because, number one, we just have to open them and we have better things to do. And number two, the other people won't be able to see the mechanisms. So I'll just start passing these around.
And while he's doing that, I have an example up here of an electronic seal. This is sort of an expensive little guy. All it does is, right down here, you put a cable in these holes and turn it on, and it generates a number. The number in this case, 5318. So if at a later time somebody comes and takes the cable out of here, you get a new number. So you come back as an inspector and you have a new number there, you know somebody's gotten to the cable and gotten into whatever you're attempting to protect.
Yeah, where's the interface to that?
Say again?
Where's the JTAG on that?
It's visual. The inspector has to come and just look at it manually, just like we are.
No, I see it, but where's the JTAG on that? And I'll give you whatever number you want.
Well, you're absolutely right. In fact, there are easier ways than the JTAG, which I'll get into in just a second. But not specifically for this device because we won't call out or pick on specific products.
I'm also going to pass out a book that's got a bunch of adhesive label seals, and you can take a look. Some of these are very frangible. Others leave behind the word void, tampering, or locked if the seal's open. One of them, even before you open it, has this big scary do not tamper, which is no doubt its best security feature because it no doubt scares the adversaries away.
All right. We've looked at, well, the results I'm going to show you are the results of looking at, in depth, 244 seals in detail. Now, we've actually looked at hundreds of more seals than this, but the results are qualitatively the same. Now, we've looked at government and commercial seals. We looked at mechanical, electronic seals, low-tech from the adhesive label stuff you're seeing to very high-tech, where fiber optic systems are used and they're looking at laser light pulses, etc. There's a cost variance of several orders of magnitude. Some of these seals are several pennies. Some of these seals are thousands of dollars a piece. Half the seals we've looked at are used in some sort of critical application or some application that folks would consider to be critical application. And 19% of the seals that we looked at involve nuclear safeguards of some sort. The results of our research is that one person using very low-tech methods can defeat half the seals in a minute or less. They can defeat 95% of the seals in under 10 minutes. Oh, sorry. My bad. Coming up. Here's our graph. 50%. Thank you. 50% of the seals in under a minute. Now, remember, some of these things are thousands of dollars. What does that tell you? Well, we work for a national laboratory, but we've never had to use the resources of a national laboratory. What we do is we go to Home Depot. We go to the local dental supply store. We go to the artisan stores, you know, paint matching, stuff like that. We've never had to get high tech on any of these seals, even the ones for nuclear safeguards, unfortunately. Here's some more statistics. The median attack time is 43 seconds. The average is a little under a minute and a half. The most telling statistic here is that we don't sit around scratching our heads trying to figure out how to defeat this stuff. The median time to develop an attack is 12 minutes. Here's some more charts for you. The top left chart there shows the attack time versus seal cost. It's a log-log chart. It's pretty scattered. There's no real good correlation here. However, if you believe that there is a slope of the line, what you get out of it is for every extra dollar you spend, you actually increase the attack time by about 270 milliseconds. So that's